All right, well, hey, welcome back, everybody. It is good to see you again. Today, we are going to learn about solving quadratic equations, of course. I see you, quadratic equation. But these are going to be equations whose answers are going to require the imaginary unit. Oh, I already dropped the marker. Ay, 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 mamma mia. Hey, what's your bright spot? Quick question for you. I'm going to pick up the marker while you think about it. My bright spot's going to be my friend group. We've been going through some things, been seeing them a lot more lately. And so it's just nice to have good friends in your life. So my friends, they're my bright spot today. All right, well, let's go get it. I actually had a student tell me, Mr. Miller, why don't you wear the hat more? I'd pay attention if you wore the hat. I said, that's all it takes is I got to wear this damn hat. I'm wearing it, baby. I'm wearing it. Let's go. Let's go. Now you got to pay attention. You know who you are. All right, so let's see what we're looking at here. So we have a quadratic equation, and we're just going to solve it like we do all of our quadratic equations. I.e., we've got our three opportunities. Ain't even going to try to factor it, but you could try to factor it. I'm going to do it two ways. I'm going to complete the square, and then I'll solve it with the quadratic formula. So let's first complete the square, because I see that middle term is even. So here we go. We've done this process quite a bit. I'm going to split the middle term up into two. You know, I'm getting too lazy. I need to bring out some different colors here, start to help your eyes out a little bit. There we go. There's that 14x. And then we have this missing square here, which is going to end up being 49 because I've done this many times and I know these dimensions are going to be x plus 7, right? X plus 7 and x plus 7. All right, I want this to be a 49. It's a 47, so let's just add 2. Add 2. You got whatever you do to one side, you got to do to the other. You knew I was going to say that. You knew I was going to say that. Ain't the first time I've said that, that's for sure. And then we get x squared plus 14x plus 49 is equal to negative 1. So x plus 7 squared is equal to negative 1. Beautiful, right? This is where a lot of times we would kind of anticipate that there's no solution, right? And in the past, you would have said there's no solution. You would have said, ain't no answer to this, teacher, because I know a little something about square roots, and I know you cannot square root a negative number. Well, if you're here, then obviously your teacher has introduced this concept of the imaginary unit. So now you're not done, but the good news is, it's kind of fun. It's not like a lot of new things here. So let's look. Here's what you got to do. I'm going to let you in on a little secret. Here's what you got to do. You're going to go plus or minus. And what you're going to do is you're going to factor out that negative 1. And I'm going to switch to purple to just kind of highlight that negative 1. So I'm going to go square root of positive 1 times the square root of negative 1. Because that is negative 1, right? 1 times negative 1. Now up here, let's just remind ourselves that the square root of negative 1 is so important in mathematics. It has its own symbol. Its own symbol is the letter I, or my electrical engineering homies would say, it's J. But we're calling it I here because we're focused in on the high school math curriculum in this video. All right, so we're going to go x plus 7. Square root of 1 is 1. So I'm going to go 1 plus or minus. So maybe I'll write 1i, and then I'll write it again. I was going to use the plus or minus, but I'll just write 2 equations here. Okay, times I. All right. All we got to do now is subtract 7 from each side, and we will be cash money. I'm going to eliminate the I from the answer there. So I'm going to go negative 7. Or not the I. I'm going to eliminate the 1, right? Because that's the invisible math. I don't have to show it. So I'm just going to go negative 7 plus I. And then over here, I'm going to go negative 7 minus I. And the little side step I didn't show is that when I subtract 7, I could put the 7 here. It's, we don't really care. It equals the same thing. Like, what I'm trying to say is you could write I minus 7. That's fine. These are the same things. But general mathematic grammar is like this. So it wants the constant first, or the real term, plus the imaginary term. And I usually put the I second. Whatever. It's all good. Let me real quickly show you how to do this with the quadratic formula. And I mean quickly. All right. Well, thank God for the play it fast little feature on the video there. So I got to here. So pause and let's just see how that was going to happen. Now there's another step where I've got to factor out a 2 up at the top because these are all even numbers. So I'm just going to reduce. But I feel like I'm running out of room, probably because I am running out of room. I guess I'll just erase this part as I don't need that anymore. So here, I'm going to just divide everything by 2. So I'm going to get negative 7 plus I, right? Because 14 divided by 2 is negative 7. 2 divided by 2 is 1. And then here, 14 divided by 2 is 7. 2 divided by 2. Why is the I? Wait, it should always be negative 14. Yeah, sorry about that. It's not plus or minus the negative 14. All right. And you can't factor these. All right, they're all none of them are going to be factorable in this case, because factoring would assume that there are x-intercepts, which there aren't. At least not real x-intercepts. So, beautiful! Let's try another one. All right, well, why don't you give this one a shot? So, hit pause, pause. Unpause. I guess that wasn't really pause. But let's get going anyway. Let's do it, baby! Let's go! I think we got this. This time I'm going to start with the quadratic formula because I see it equals 0. So what the hell? You only live once. Let's just do it. So I'm going to do negative b. So b is minus 10. Let's just kind of make sure we're on board with a being 1, b being minus 10, and c being positive 34. All right? So plus or minus the square root of negative b squared minus 4 times a times c. All of that is over 2 times 1. I don't know how to make it sound beautiful. I wish I could. I wish I could. I would be a millionaire. All right. So we got 10 here, plus or minus the square root of 100 minus, now we should anticipate this number is going to be bigger than 100 because the square root has to be negative if it's going to have a complex solution. So what do we got? 4 times 30 is 120. And then we got 4 times 4 is 16, so that's 136. There we go. Gorgeous. Let's keep going this way. All right. So let's simplify this radical. So we got 10 plus or minus the square root of negative 36 over 2. So here's some fun. Why don't you pause it and see if you can't take that a little further. Pause. Unpause. Let's keep going. So 36 is a perfect square, right? So what we're going to do is go 10 plus or minus positive 36 times negative 1. There we go. That's how we treat the negative square root. We just times that damn thing by negative 1, make the square root positive, and do exactly what we've been doing with that positive square root. Let's keep going. Let's keep going. Hell, you only live once. All right, here we go. Feeling good about this. Marginally. It's like, why did you have to qualify that, Mr. Miller? First thing you did is you said you feeling good, and then you had to go say marginally. All right, so there we go. Got even numbers all over the place, so I can at least divide these all by 2. Or I could show, if that's helpful, I could show a factoring out of a 2. I didn't do that last video, but I could show that. Keep the eye purple just for fun. All right. Now those two cancel. A lot of people tell me, Mr. Man, they don't actually cancel. Okay. You can say they reduce to 1. Okay, this is okay. This is okay. 5 plus or minus 3 times I. Beautiful. Gorgeous, Mr. Miller. Hey, Mr. Miller, why don't you solve that thing using completing the square / that quadratic method? All right, let's do it. And I'm going to do this one a lot faster. Yes! Yes! They're the same answer! They must be correct. How gorgeous is that? And it's kind of cool to see where that -9, see that -9 here was 36, but we had to divide by 2, which we didn't have to divide by 2, so it was just -9. I feel like we've been on quite a journey today. I want to give you one more to practice, so let's do it. I know you're getting tired. I can see it. So I don't know how smooth that transition was, but here's the problem that I want you to do this time. All right, last one. So hit pause and let's roll. Unpause. Let's get it. All right, so what I'm going to do first is quadratic formula. I feel like that's more of what more people are using these days. So I'm going to make this thing equal to 0 by adding 15. So I get 16 is 0. Now I've changed the form to the beautiful quadratic formula. I'm going to do this one super fast. Oh, I should probably pause here because now we have a square root that needs to be simplified, but it's not a perfect square like the first 2 videos. Well, let's just kind of see how we're going to handle that. So what I'm going to do is 48 is 16 times 3. So 48, I want to find a factor, right? I want to find a factor that's a perfect square. So that's the 16. So I'm going to rewrite this as 16 times 3. And of course, because it's negative, I'm going to do the times -1. Because really, as I kind of maybe should have shown that step, when it's really, you change -48 to +48, multiply that thing by -1, and keep on going. So here we go. The quadratic formula does have a lot of simplifying, more than when we complete the square for sure. Okay, so we got 4 root 3 times I all over 2. And maybe you're starting to see that divide by 2, you got even numbers all over the place. Let's just reduce 4 divided by 2 to be 2. Let's reduce 4 divided by 2 to be 2. And again, the order here doesn't matter. It matters, I guess, if your teacher asks you to make it look like that, then you should put the number and end with the I, right? The I should come last, but whatever. It's all good. It's beautiful. So are you. And I was going to do it with the quadratic method, but I'm tired. You're going to get that same answer. All right. I hope this video finds you well. It's found me well enough. I said something about my friends earlier. Some of them had a difficult medical diagnosis, so that's on my mind. So why don't you send love to your friends? Let them know you love them. It's okay. So you can tell them you love them. And yeah, let's stay together. That was a hug. Okay? People need a hug. You never know. So take care. I believe in you. Let's go get it.